Okay, so now let's go to the setter side. So at the top we can toggle the button and go to the login page of setter. Similarly, we can sign up as a setter, but the difference here is that once we sign up we need admin approval, which we will see from the admin side, and then we will get a email verification, and then we can log into our account. So I am logging in an existing setter account. Okay, so the main work of setter is that he will set some problems. So here is the list of previously set problems. From here I can preview the previous problems, or I can edit a problem, or I can clone a problem, which means I can copy a problem and create a new problem. So, and lastly, I can remove a problem only if the problem is not published in the user side. In that case, we cannot delete that. As you can see, these problems are published in the user side, so the delete button is disabled. These are not published in the user side, so we can delete this. And we can also create new problem by adding a new problem. So I need to give a title to the problem. Okay, so I'm on the problem edit is problem setting page. So here I can see at the left I have some tabs: details, canvas, solution, and test. And at the right I have the option to publish the problem. So let's see one by one. First I need to set a statement from the problem. So this is a basic markdown editor but with LaTeX support. So I can write equations also. As you can see, I can use LaTeX here. Then I can just save the statement. Then I'll go to the main part, which is canvas. Okay, so here I can see an empty canvas, but I have a canvas as option where I can choose canvas. Here I have three options: an array canvas, then an Tower of Henry canvas, then an graph canvas. So I will go one by one. Okay, so here I can see some option to add node, add edges, clear canvas, and some options that I will show later. So let's first create a node. If we click that button, we can see a different cursor where it is said that click anywhere in the canvas to add a node. So I can click anywhere in the canvas to add a node. Then I can drag the nodes. Also, if on clicking a node, I can change the node level. Also, I can change the color of the nodes. Then after adding nodes, I need to add the edges. So I will choose edge, and then I will follow the instruction which says that click on two nodes to add an edge between them. So I will click one and then one node. In this way I can add edges. On clicking an edge, I can add weight to it. So here I can see some options. If we see, we have two options. We can make the canvas directed edge. Also, we can make the edges weighted. So once we have done that, we can choose a canvas and then we can increase the weight, or we can just remove a edge. Also we can remove nodes. On deleting a node, the edge will also be deleted. So I can also clear the canvas, and then if I show another option, let's create a canvas first. Okay, so I have created a canvas, and then I will, from here I can see a I button, which basically on clicking that I will switch to preview mode. What preview mode is, this is the view what an user will see. So a setter can control what a user can see and what he can do with the canvas. For that we have some preview options. Here I can see I have the option to toggle the add node, which means if I mark it, an user can add nodes to a graph, then delete node, then drag node, etc, etc. Without this option enabled, I cannot drag a node or delete edges or do anything. But if I say enable the drag node option, I can drag nodes. So this is a very handy way to control what a user can do. Otherwise, if we give access to everything, a user will delete everything and create his own graph. So the solution checking process will be difficult. So we are doing that for that reason. Okay, now we can see the Tower of Hanoi canvas. Here at the top you can see the option to choose the number of disks. We can increase the disk, or we can set a custom disk from here like that. We can choose disk of different sizes from under here. In this way we will create a Tower of Hanoi problem. Let's see the array canvas. So here we have the option to make it 2D array. Basically this is the number of rows and this is the number of columns. So we can make any array related problem from here. If we see, we can choose a element and change its value. Also, if I choose two elements, then I have the option to swap them. As you can see, 5 and 6 are swapping. Or I have the option to reverse the sub-array. So this sub-array will be reversed now, as you can see. And then I have the option to sort this sub-array in descending order. As you can see, 6, 5, 4, 4, 3. Then I have the option to sort the sub-array in ascending order. Then I have another option to rotate one element left. As you can see, here is 6. If we press the rotate left, 6 will be here and 5 will be there. And similarly a rotate left option. Okay, so see here also we have the preview option. From here we can control what a user can do with this array. First of all, if a user can drag elements, by dragging I mean this part, you can just drag a node and insert anywhere. Let me demonstrate. Like this, you can just drag and insert anywhere. But if I want that user won't be able to drag elements, I can just disable the option. Now user can't drag the anywhere, and also I can limit how much sub array can user can choose. So if I choose swap equal to 2, so then a user cannot swap more than that. He can at most swap elements which distance is at most 2. So as you can see, on choosing these two we have got the swap option, but if we choose a more than that, we won't find that. Similarly, this is the option for all other. Okay, so then we need to demonstrate the solution and test process. For that, we will demonstrate with an existing problem. Let's see. Okay, so I am seeing an road construction which is basically a minimum spanning tree problem. Here is the statement, then the canvas, and then the solution. So we are just what MST do. So in MST we need to choose a subtree which is the minimum weight. So here I have just chosen the subtree which has the minimum weight. Then when a user submits a problem, I just compare his graph with mine. If it matches, then the verdict will be accepted, otherwise wrong answer. So for that, what I am doing is I am setting preview option. All of them are disabled. We can see why. Because if we, let's say, have the option to drag node, then user can drag nodes and then submit. So that will make the solution checking process a little bit difficult. So we are not doing that. Okay, then now we have make a solution. After creating the solution, we can test if the solution is working or not. Here is what a user will see. So user cannot drag the nodes or do anything else. He can just select the edges. So if I just select these edges and submit, I will get wrong answer. But if I choose the correct answer, like the solution I have shown you just now, I can see that it is accepted. So now the question is, will this solution checking process always work? What if a graph has multiple MST? What we'll do then? So for that we have make a workaround, which is a code editor. So on clicking at the bottom right, we can switch between solution canvas and solution code editor. So by default we are just taking the user canvas and the solution canvas and just checking if they are equal. So this is the code that is working on the background. So here we have given the option to the setter that he can override this function. So with this power he can make any solution checker as he wants. So let me show the options we have given in this code editor. First of all, on creating a new problem, let's say he has created a problem on graph. So a template will be given to create the solution in checker by default, which is this. This can be modified from our admin site, which we'll show later. So from the comments, a setter can see what actually is this parameters are passed to the function, so he can modify the code accordingly. So let's say we want to print and check what is this user canvas all about. Okay, so if I run this run button, I can show a new panel which just show me the output. I can toggle this button and hide the output. So this is how the code editor works with the solution checker. So this solution checker solution is converted to a JSON and then passed to the solution checker function. And when a user submits a canvas, his canvas is also passed to this solution checker function. So let's see a problem where we have overwritten the default code. Okay, so this is the road construction 2. Here we can see that it has multiple MST. Let's say this is a minimum spanning tree, this is a minimum spanning tree, also this is a minimum spanning tree. So if we just check based on the canvas, we will give wrong verdict to even accepted answers, so that won't be acceptable. Now if we just check the test, so in the solution we have seen that we have chosen this edge in the solution. Let's see if it is accepted or not. But what if I choose the another edge which is also minimum spanning tree? This should be accepted, and it is accepted. But according to what we have seen, if we just match this graph to the user graph, that will be a mismatch. So here we have overwritten the code, and as you can see, this is a big code where we have taken the user canvas and then check that if the user canvas and the solution canvas has the same weight or not. Not the whole graph need to be same, just the summation of weight must be same. This way an problem setter can build the solution. After he has built the solution and the problem, he can save it and then he can publish it. So on publishing a problem, the problem won't be immediately shown to user. It will be pending. Only if admin accepts a problem or approves a problem, then the problem will be shown to the user side, which we'll see when we will demonstrate the admin side. So this is all about how a problem setter can set a problem. Next up, we will see how a problem setter will create articles